Okay guys, so we're going to be covering the quadratic formula today and the discriminant value, which is something that's within the quadratic formula. But before we begin that, we should review some Algebra 1 stuff here with this class opener. How do you find the x and y intercepts of a line? You guys remember that? The algebraic way to find the x and y intercepts of a line? And we already know, or we should know, that the x-intercept is where the line crosses the x-axis. The y-intercept is where the line crosses the y-axis. But does anybody remember how to do it algebraically? How do you find the x-intercept? Maybe that should help you out. X int, y int. You guys remember that? And we did some work on both sides. What kind of work did we do? How do we find the x-intercept? We set y equal to 0. How do we find the y-intercept? Set x equal to 0. So we're going to do both of those. On the x-intercept, I'm going to take the y value and set it equal to 0 and rewrite the whole thing. So it will be 0 equals 2x minus 4, and everybody should be following along right here on your paper. And when I solve this, I'm going to go plus 4, plus 4. I'm going to have 4 equals 2x, and for my final step, I divide by 2 and divide by 2, which means that my x-intercept value is what? X equals 2. 4 divided by 2 is 2. That's our x-intercept value. Let's go for the y-intercept. Let's set x equal to 0. So I'm going to rewrite this equation, but instead of x, I'm going to put 0 right in there. So let me do that. And there it is, y equals 2 times 0 minus 4. So 2 times 0 is obviously 0. 0 minus 4 is minus 4. So the y-intercept is negative 4. Okay? What does that really mean that this line, which is already in slope-intercept form, crosses at negative 4 and it goes up 2 over 1 because of the slope, but it pretty much tells you that on a xy plane, the x-intercept is 2. So on the x-axis, this is the x-axis, it's going to cross at 2 right there, and then on the y-axis, it's going to cross at negative 1, 2, 3, 4 right there. So your line is pretty much right through those 2 points. So that's just a review of finding x and y intercepts. Why? Because we're also going to find x and y intercepts with parabolas, with quadratic equations. And it's the same exact concept. To find the x-intercept, you set y equal to 0. To find the y-intercept, you set x equal to 0. Now, on today's actual lesson, we also need to remember how to simplify radicals. Now, we've already done this in the past. Hopefully, you guys remember how to simplify the square root of 24. Remember, we want a perfect square number inside the radical. We would love to have a square root of 25 because the answers would be what? 5. We'd love to have a square root of 64 because the answer would be what? 8. So if you have a perfect square number in there, that would be awesome. Now 24 is not a perfect square number. So what we need to do is rewrite it with multiplication to get a perfect square number. So obviously I'm not going to rewrite it at 2 times 4 because, not 2 times 4, 2 times 12 because 2 is not a perfect square and 12 is not a perfect square. But then again, we could use the factor tree if we wanted to just break it down as much as we can. But I want to think of a perfect square number. The first perfect square number is 4. So will 4 work? 4 times something give you 24? Yes. So let's rewrite it as 4 times 6. Now, why would I want to rewrite it as 4 times 6? Because 4 is a perfect square number. And I am going to now split the root into both of them. And I will get the final answer, or final simplified expression of 2 square root of 6. And that's it. Now the square root of 6, you can't continue breaking that down because if you broke it down to 2 times 3, 2 is not a perfect square, 3 is not a perfect square. Number 3, the square root of 32. I need a perfect square number in there. It would be nice if instead of 32 it was 36, but it's not. So I need to get a perfect square number in there. So what am I going to rewrite this as? 8 times 4. Now let's put the perfect square number first, right? Okay, so you could go, I'm going to rewrite this to 4 times 8, right? And then that would still be in there. We're going to split the root, square root of 4, square root of 8. The square root of 4 is 2. The square root of 8, could you break that down further? Yeah, 4 times 2, right? So you could break down the square root of 8 and rewrite it as 4 times 2, bring down the 2 that's in the front, and then split the square root to the 4 and to the 2 and bring down the 2. And then you could say the square root of 4 is 2, And of course, you have the 2 out here in the front, which is 2 times 2. And don't forget about the square root of 2 that's at the very end. So your final answer is 4 square root of 2. If you understand that, that's great. But the better thing to do, instead of jumping on the very first perfect square number, would be to think a couple more seconds of a higher perfect square number. So we all thought, yeah, 4 works. 4 times 8 is 32. Let's go for the next perfect square number. How about 9? Will 9 times something give you 32? No. How about the next highest perfect square number? 16, right? 16 times what gives you 32? 2. So you could have, from the beginning, wrote it as 16 times 2, and you'll get that same answer down there, 4 square root of 2, because the square root of 16 is 4, and the square root of 2 stays square root of 2. So it's totally up to you. Probably want to go this route if you're bored on a Saturday night, right? But if you want to get the question done quickly, go for the highest perfect square number like 16 as opposed to your first perfect square number 4. Okay. Now sometimes you could only break it down with 4, then yeah, go ahead, use 4. But try a couple of seconds more, think about the higher perfect square number that would work. Let's look at number 4 right here, 108. So you might need a calculator as well. If you do have a calculator, if you try 108 divided by 4, that might give you something that works, right? But does that mean we should use the 4? No, we should try a higher perfect square number. So obviously, like a higher perfect square number like 25. 25 is not going to work because we all know quarters. You're either going to have 50 cents, 75 cents, $1, $1.25, $1.50, not $1.08. So 25 wouldn't work. Could anybody think of a higher perfect square number that would work with 108? Somebody said it. 36. 36, right? And of course, if you have a calculator, just, try it out. Try 108 divided by 36 or 108 divided by 49. It won't work. But 108 divided by 36, it will work. And it'll be 36 times 3. So if you split the root, you'll be done 6 square root of 3. Now this was back a while back when we were simplifying radicals. And you're probably thinking, why are we doing this? Because today we're going to learn the quadratic formula. And the quadratic formula has a square root within the formula. And you have to be able to break down that square root the way we just did right now in the class opener. So this class opener is filled with the skills that we need for today's actual lesson on the quadratic formula.